Hello and welcome to Code Skwela. Join me as we continue our CS50 Computer Science course, and now we are at hour number 3, or the third hour of this 25-hour course. And so, yeah, uh, this could take a while. So, yeah, we're only in our third hour. And so, yeah, I think as a recap, if I could uh, pull, check out my notes from the previous previous hour of lecture. So yeah, I think not much has I've taken not that much from that hour of lecture, because yeah, it was mostly discussing about VS Code, compilers, and C. So it included an introduction to the C programming language, and so yeah, this hour will be a continuation of it. So uh, join me as we go through this another hour of lecture for the CS50 Computer Science course. And let's continue. So yeah, let's hit play for this one, and yeah, hopefully we'll learn uh, new things for this one. So yeah, let's start.
Inventors of this and this operating system and its predecessors were very succinct. Like the command is rm for remove. The command is ls for list. It's very terse. Why? Because it's just faster to type. So before we forge ahead with making something more interesting than just hello world, let me pause here to see if there's questions on source code or machine code or compiler or this command line interface. Yeah. Really good question, and let me recap. If I were to make changes to the program, run it, and then maybe make other changes and try to rerun it, would those changes be reflected, even though I've reworded slightly? Well, let's do this. I already removed the old version, so let me go ahead and point out that if I do /hello now, I'm going to see some kind of error because I just deleted the file. No such file or directory, so it's not terribly user-friendly, but it's saying what the problem is. Let me go ahead and remake it by typing make hello. Now, if I type ls, I'll see not one but two files again. And one of them is even green with a little asterisk to indicate that it's executable. It's sort of the textual version of something you could double click in our human world. So now, of course, if I run hello, we're back where I started, hello world. But now suppose I change it to hello, CS50, like I did years ago. Let me go ahead and save the file with Command S or Control S. Down here now, let me run /hello again, and voila. So let me ask someone else to answer that question. What's the missing step?
You need
Why
to
did it not say hello CS50?
Yeah, you have not recompiled the
Yeah,
program.
so I didn't compile it again. So sort of newbie mistake. You're going to make this mistake and many others before long. But now let me go ahead and remake hello, enter. It's going to seemingly make the same program. But this time when I run it, it's hello CS50. All right, any other questions on some of these building blocks? And we'll come back to all the crazy syntax I typed before long. But for now, we're focusing on just the output. Yeah? When I keep running make, it creates a new version of the machine code. So it keeps changing the hello program in the hello file, and that's it. There's no make file per se. Good question. No. If I open up that directory, you'll see that there's just the one. And it doesn't matter how many times I run make hello, 3, 4, 5, it just keeps overwriting the original. So it's kind of like just saving in the world of Google Docs or Microsoft Word or the like. But there's an additional step today. We have to then convert my words to the computers, the zeros and ones. Yeah, in front. What happens if I run hello.c? So let me go ahead and do /hello.c, which is a mistake you'll invariably make early on, permission denied. So what does that mean? This is where the error messages mean something to the people who design the operating system, but it's a little cryptic. It's not that you don't have access to the file. It means that it's not executable. This is not something you have permission to run, but you do have permission to read or write it. That is, change it. Really good question. So if I have named my file hello.c, or more generally something.c, one of the things that make does is it automatically picks the file name for me. And we'll discuss this a bit more next week. Make itself is kind of the first of white lies today. Itself is not a compiler. It's a program that knows how to find and use a compiler on the system and automatically create the program. If I use, as we'll discuss next week, the actual compiler myself, I have to type a much longer sequence of commands to specify explicitly what do I want the name of my program to be. Make is a nice program, especially in week 1, because it just automates all of that for us. And so here we have now a program that very simply prints something on the screen. So let's now put this into the context of where we left off last time, in the context of Scratch and inputs and outputs. So we discussed last time, of course, functions and arguments. Functions, again, are those actions and verbs like say or ask or the like. And the arguments were the inputs to those functions, generally in those little white ovals that in Scratch you could type words or numbers into. We'll see, and all of the languages we're going to see this term have that same capability. And let's just start to translate one of these things to another. So for instance, let's put this same program in C in the context of Scratch. This is what hello world looked like last week in the form of one function. This week, of course, it looks like print, and then the parentheses, notice, are kind of deliberately designed in the world of Scratch to resemble that same shape. Even though this is a white oval, you kind of get that it's kind of evoking that same idea with the parentheses. Technically, the function in C, it's not called say. It's not even called print. It's called printf. The F stands for formatted, but we'll see what that means in a moment. But printf is the closest analogous function for say in the world of C. Notice if, though, you want to print something like hello world or hello CS50 in C, you don't just write the words as we did last week. You also had to add what, if you notice already what's missing from this version? Yeah, so the double quotes on the left and the right. So that's necessary in C whenever you have a string of words. And I'm using that word deliberately. Whenever you have multiple words like this, this is known as a string, as we'll see. And you have to put it in double quotes. Not single quotes. You have to put it in double quotes. There's one other stupid thing that we need to have in my C code in order to get this function to do something ultimately, which is what?
So think of strings as a sequence of characters, okay? So those characters would be the ones that are available in ASCII code or in Unicode.
Semicolon. So just like in our human world, you eventually got into the habit of using, at least in formal writing, periods. Semicolon is generally what you use to finish your thought in the world of programming with C. All right, so we have that function in place. Now, what does this really fit into in terms of the mental model? Well, functions take arguments, and it turns out functions can have different types of outputs. And we've actually seen both already last week. One type of output from a function can be something called a side effect. And it generally refers to something visual, like something appearing on the screen or a sound playing from your computer. It's sort of a side effect of the function doing its thing. And indeed, last week we saw this in the context of passing in something like hello world as input to the say function. And we saw on the screen hello world. But it was kind of a one-off. It's one and done. You can't actually do anything with that visual output other than consume it visually with your human eyes. But sometimes, recall last week, we had functions like the ask block that actually returned me some value. Remember the ask, what's your name? It handed me back whatever answer the human typed in. It didn't just arbitrarily display it on the screen. The cat didn't necessarily say it on the screen. It was stored instead in that special variable that was called answer, because some functions have not side effects but return values. They hand you back an output that you can use and reuse, unlike the side effect, which again displays and that's it. You can't sort of catch it and hold on to it. So in the context of last week, we had the ask block, and that had this special answer return value. In C, we're going to see in just a moment, we could translate this as follows. The closest match I can propose for the ask block is a function that we're going to start calling getString. String is, again, a word, a set of words, like a phrase or a sentence in programming. It, too, is a function insofar as it takes input. And pretty much, this isn't always true, but very often when you have a word in C followed by an open parenthesis and a closed parenthesis, it's most likely the name of a function. And we're going to see that there's some exceptions to that. But for now, this indeed looks like a function because it matches that pattern. If I want to ask the question, what's your name? Question mark. And I'm even going to deliberately put a space there just to kind of move the cursor a little bit over so that the human isn't typing literally after the question mark. So that's just a nitpicky aesthetic. This is perhaps the closest analog to just asking that question. But because the ask block returns a value, the analog here for getString is that it too returns a value. It doesn't just print the human's input. It hands it back to you in the form of a variable, aka a return value, that I can then use and reuse. Now, ideally, it would be as simple as this, literally saying answer on the left equals. And this is where things start to diverge from math and sort of our human world. This equal sign, henceforth, is not the equal sign. It is the assignment operator. To assign a value means to store a value in some variable. And you read these things, weirdly, right to left. So here is a function called getString. I claim that it's going to return to you whatever the human types in as their name. It's going to get stored over here on the left because of this so-called assignment operator. That yes is an equal sign, but it doesn't mean equality in this context. It makes things equal, but it does so by copying the value on the right into the thing on the left. Unfortunately, we're not quite done yet with C. And this is where, again, it gets a little annoying at first, where Scratch just let us express our ideas without so much syntax. In C, when you have a variable, you don't just give it a name like you did in Scratch. You also have to tell the computer in advance what type of value it is storing. String is one such type of value. Int for integer is going to be another. And there's even more than that we'll see today and beyond. And this is partly an answer to the question that came up one or more times last week, which was, how does a computer distinguish this pattern of zeros and ones from this? Like, is this a letter, a number, a color, a piece of video? And I just claimed last week that it totally depends on the program. It depends on the context. And that's true. But within those programs, it often depends on what the human programmer said the type of the value is. This specifies it's a string, which means interpret the following zeros and ones that are stored in my program as words or letters more generally. If it said int for integer, it would be implying by the programmer, treat the following zeros and ones in my program as a number, an integer, not a string. So here's where this week, unlike with Scratch, which just kind of figures out what you mean, with C in a lot of languages, you have to be this pedantic and tell it what you mean. There's still one stupid thing missing from my code here. What's still missing here? Yeah? And we still need the stupid semicolon. And I'm sort of impugning it here because, honestly, these are the kinds of stupid mistakes you're going to make today, tomorrow, this weekend, next week, a few weeks from now, until you start to notice this and recognize it as well as you do English or whatever your spoken language.
So, yep, back when I was starting learning about C, one common mistake or error that would come up when you try to compile your C code is that you're missing something in that line, and then you end up with just missing that semicolon. And what's weird also is that I don't know if it's because of the compiler. It would say that the error is in this line, but actually the actual line that's causing it is before it. So yeah, it's kind of weird thing to experience that kind of way of programming with C, but yeah, I guess that's just how it's a compiler way of doing things. So yeah.
Yeah, question. Good question. Suppose I mix apples and oranges, so to speak, and I try to put a string in an int or an int in a string. The compiler is going to complain. So when I run that make command, as I did earlier, it's not going to be nice and blissfully quiet and just give me another prompt. It's going to yell at me with, honestly, a very cryptic-looking error message.
So one idea also of programming languages is this, what they call data types. So what he just mentioned, like we have strings, numbers. So when you are trying to deal with values, different programming languages provide different type of data. Okay, so that means that a data type or a certain value could be a string, which is just a sequence of letters and numbers and whatever symbols, and then it could also be a number. It's basically the 0, 1, and up to 9. And then depending on the type of data that you'll be working with, it has specific. I mean, it functions differently. Like for example, when you reach the point where you will be working with operators, like for example addition. So the addition operator could work differently when you're dealing with strings, and then it could also work differently when you're dealing with numbers. Okay, and also with The example with the equal sign. So yeah, with the equal sign, it's not comparing whether two values are the same, but it's assigning a value to a certain variable. Okay, so those just are the things that could get weird at the start when trying to learn programming languages. But yeah.
Until we get the muscle memory for reading it. Other questions? What happened to the \n? So we'll come back to that in just a moment if we may, because I have deliberately omitted it here, but we did have it earlier, and we'll see the different behavior in a sec. Other questions? Yeah, not at all nitpicky. These are the kinds of things that just matter, and it's going to take time to recognize and develop this muscle memory. Everything I've typed here, except for the W at the moment, is lowercase. And the W is capitalized just because it's English. Everything else is lowercase. And this kind of varies by language and also context.
Yeah.
So in many languages, the convention is to use all lowercase letters for your variable names. Other languages might use some capitals as well, but we'll talk about that before long. But this is the kind of thing that matters and is hard to see at first, especially when a little s doesn't look that different, when it's on your tiny laptop screen from a capital S, but you'll start to develop these instincts. All right, so besides this particular block, let's go ahead and consider how we can go about implementing this now in code. So let me switch back to VS Code here. This was the program I had earlier, and let me go ahead and undo my CS50 change, and this time just rerun make on hello with the original version with the \n. Enter. Nothing bad seems to have happened, so /hello. Enter. Hello world. Now, if you're curious, this is a good instinct to start to acquire. What happens if I get rid of this? Well, I'm probably not going to break things too badly, so let's try. Let me go ahead now and do make hello. Still compiles, so it's not a really bad mistake. So let me go ahead and run /hello.
Yeah.
What's the difference here? Yeah, what do you see that's different? Yeah, the dollar sign, my so-called prompt, stayed on the same line. Why? Well, we can presumably infer now that the \n is some fancy notation for saying create a new line. Move the cursor, so to speak, to the next line. Notice that the cursor will move to the next line in my terminal window. If I keep hitting it, it just automatically, by nature of hitting enter, does it. But it'd be kind of stupid if when you run a program in this world, simple as it is, if like the next command is now weirdly spaced in the middle of the terminal with the dollar sign. It just looks sloppy, right? It's really just an aesthetic argument. And notice that it's not acceptable or correct to do this, to hit enter there. Let me go ahead and save that, though, and see what happens. Let me go ahead now and run make hello, enter. Oh my god, like 4 errors. This is like, what, 10 lines of errors for like a 1-line program? And this is where, again, you'll start to develop the instincts for just reading this stuff. These kinds of tools, like the compiler tool we're using, were not designed necessarily with user friendliness in mind. That's changed over the decades, but certainly early on, it's really just meant to be correct and precise with its errors. So what did I do here? Missing terminating close quote character. Long story short, when you have a string in C, your double quotes just have to be on the same line, just because. Now, there's the slight white lie. There's ways around this, but the best way around it is to use this so-called escape sequence. To escape something means generally to put a backslash and then a special symbol like N for new line. And this is just the agreed upon way that humans decades ago decided, OK, you don't just hit your enter key. You instead put \n, and that tells the computer to move the cursor to the new line. So again, kind of cryptic, but once you know it, like that's it. It's just another word in our vocabulary. So now let me transition to making my program a little more interactive. Instead of just saying hello world, let me change it like last week to say hello David, or whoever's interacting with the program. So I'm going to do string answer gets, get string, quote unquote, what's your name? I'm not going to bother with a new line here. I could. This is now just a judgment call. I deliberately want the human to type their name on the same line, just because. And how do I now print this? Well, last week, recall, we used say, and then we used the other block called join. So the idea here is the same, but the syntax this week is going to be a little different. It's going to be printf, which prints something on the screen. I'm going to go ahead and say hello, comma, and let me just go with this initially, with the \n, semicolon. Let me go ahead and recompile my code. Whoops. Damn, doesn't work still. And look at all these errors. Like there's more errors than code I wrote. But what's going on here? Well, this is actually something, a mistake you'll see somewhat often, at least initially. And let's start to glean what's going on here. So here, if I look at the very first line of output after the $sign, so even though it jumped down the screen pretty fast, I wrote make hello at the $sign prompt. And then here's the first error. On hello.c, line 5, technically character 5, but generally line is enough to get you going. There's an error. Use of undeclared identifier string. Did you mean standard in? So I didn't. And this is not an obvious solution at first, but you'll start to recognize these patterns in error messages. It turns out that if I want to use string, I actually have to do this. I have to include another library up here, another line of code, rather, called CS50.h. We'll come back to what this means in just a moment. But if I now retroactively say, all right, what does standard I/O do for us up here? Before I added that new line, what is standard I/O doing? Well, if you think back to Scratch, there were a few examples with like the camera and with the speech to the text to voice. Remember, I had to poke around in like the extensions button, and then I had to load it into Scratch. It didn't come natively with Scratch. C is quite like that. Some functions come with the language, but for the most part, if you want to use a function, an action or verb like printf, you have to load that extension, so to speak, that more traditionally is called a library. So there is a standard I/O library, stdio, standard I/O, where I/O just means input and output, which means, just like in MIT's world, there was an extension for doing text to voice or for using your camera. In C, there's an extension, aka a library, for doing standard input and output.
Yeah.
And so if you want to use any functions related to standard input and output, like keyboard, text from a keyboard, you have to include standard io.h. And you have to, then can you use printf. Same goes here. GetString, it turns out, is a function that CS50 wrote some time ago. And as we'll see over the coming weeks, it just makes it way easier to get input from a user. C is very good with printf at printing output on the screen. C makes it really annoying and hard, as we'll see in a few weeks, to just get input from the user. So we wrote a function called getString, but the only way you can use that is to load the extension, aka load the library called CS50. And we'll come back in time, like why is it .h, why is it a hash symbol? But for now, standard I/O is a library that gives you access to printf and input and output related stuff. CS50 is a second library that provides you with access to functions that don't come with C that include something like getString.
So these include lines at the top. You can think of it as like borrowing functions from other programs. So those two that have been set as like stdio.h and then the cs50.h, those are still programs that's already been defined or created by someone else, and so you can just borrow those functionalities that were created on those programs. Okay.
So with that said, we've now kind of teased apart at a high level what lines 2 and now 1 are doing. Let me go ahead and rerun make hello. Now it worked. So all those crazy error messages were resolved by just one fix. So key takeaway is not to get overwhelmed by the sheer number of errors. Let me now do /hello. And if I type in my name, what am I going to see?
Hello answer. Yeah.
What do you think?
Would still be hello answer.
Yeah, hello answer, because the computer is going to take me literally. And it turns out that if you just write hello, comma, answer all in the double quotes, you're really just passing English as the input to the printf function. You're not actually passing in the variable.
Taking
And
things
unfortunately in C, it's not
the double
quite as
quotes.
easy to plug things in to other things that you've typed. Remember in Scratch, there was not just the say block, but the join block, which was kind of pretty. It does, you can combine apples and oranges, or what was it, apple and banana. Then we changed it to hello, and then the answer that the human typed in. In C, the syntax is going to be a little different. You tell the computer inside of your double quotes that you want to have a placeholder there, so-called format code. %s means, hey, computer, put a string here eventually. Then, outside of your quotes, you just add a comma, and then you type in whatever variable you want the computer to plug in at that %s location for you. So %s is a format code, which serves as a placeholder. And now the printf function was designed by humans years ago to figure out how to do the apple and banana thing of joining two words together. It's not nearly as user-friendly as it is in Scratch, but it's a very common paradigm. So let me try and rerun this now. Make hello. No errors. That's good. /hello. What's my name? David. If I type enter now, it's hello, David. And the printf, here's the f in printf. It formats its input for you by using these placeholders for things like strings, represented again by %s. So a quick question then. If I focus here on line 7 for just a moment and even zoom in here, how many inputs is printf taking as a function? A moment ago, I'd admit that it was taking one input, hello world, quote unquote. How many inputs might you infer printf is taking now? 2. And it's implied by this comma here, which is separating the first one, quote unquote, hello, %s, from the second one, answer. And then just as a quick safety check here, why is it not 3? Because there's obviously 2 commas here. Why is it not actually 3 arguments or inputs?
Because the %s
exactly.
is
The
part
comma
of the input.
to the left is actually part of my English grammar. That's all. So same syntax. And again, here's where, again, programming can just be confusing early on because we're using the same special punctuation to mean different things. It just depends on the context. And so now is actually a good time to point out all of the somewhat pretty colors that have been popping up on the screen here. Even though I wasn't going to like a format menu, I wasn't bold-facing things, I certainly wasn't changing things to red or blue or whatnot. That's because a text editor like VS Code syntax highlights for you. This is a feature of so many different programming environments nowadays. VS Code does it as well. If your text editor understands the language that you're programming in, C in this case, it highlights in different colors the different types of ideas in your code. So for instance, string and answer here are in black, but getString, a function, is in this sort of nasty brown yellow here right now. But that's just how it displays on the screen. The string, though, here in red is kind of jumping out at me, and that's marginally useful. The %s is in blue. That's kind of nice because it's jumping out at me. And so it's just using different colors to make different things on the screen pop so you can focus on how these ideas interrelate. And honestly, when you might make a mistake. For instance, let me accidentally leave off this quote here. And now all of a sudden, everything, notice, if I delete the quote, the colors start to get a little awry. But if I go back there and put it back, now everything's back in place. What's another feature of this text editor? Notice when my cursor is next to this parenthesis, which demarcates the end of the inputs to the function, notice that highlighted in green here is the opening parenthesis. Why? It's just a visually useful thing, especially when you start writing more and more code, just to make sure your parentheses are lining up. And that's true for these curly braces over here on the left and the right. We'll come back to those in a moment. If I put my cursor there, you can see that these things correspond to one another. So it's nothing in your code fundamentally. It's just the editor trying to help you, the human, program. And you can even see it, though it's a little subtle. See these 4 dots here and these 4 dots here? That's my indentation. I'm configured VS Code to indent by 4 spaces, which is a very common convention. Anytime I hit the tab key, this too can help you make sure, once we have more interesting and longer programs, that everything lines up nice and neatly. Whew. All right, any questions then on printf or more? Yeah. Short answer, yes. Printf can handle more than one type of variable or value. %s is one. We're going to see %i is another for plugging in an integer. You can have multiple i's, multiple s's, and even other symbols too. We'll come back to that in just a little bit. Printf can take many more arguments than just these 2. This is just meant to be representative. Yeah, over here. Can you declare variables within the printf? No. The only variable I'm using right now is answer, and it's got to be done outside the context of printf in this case. Good question. We'll see more of that before long. Yeah, in back. How do we download the CS50 library? So we will show you in problem set 1 exactly how to do that. It's automatically done for you in our version of VS Code in the cloud. If ultimately you program on your own Mac or PC, either initially or later on, it's also installable online. But if you want to ask that via online or afterward, we can point you in the right direction. But pset 1 will itself. Yeah. String is the type of the variable, or more properly, the data type of the variable. Int is another keyword I alluded to earlier. Haven't used it yet. Int for integer is going to be another type or data type of variable. Yeah. Good question. Could I go ahead and just plug in this function, kind of like we did in Scratch, getting rid of the variable altogether, and just do this, which recall is reminiscent of what I did in Scratch by plopping block on top of block on block? Am I answering that right? Can I put string in front of getString? No, you only put the word string in front of a variable that you want to make string. And even though I'm apparently answering the wrong question, let me go ahead and zoom out, save this, do make hello again. Seems to compile OK. If I run /hello, type in David, voila, that too works. And so actually, let's go down this rabbit hole for just a moment. Clearly, it's still correct, at least based on my limited testing. Is this better designed or worse designed? Let's open that question like we did last week, yeah? Yeah, I kind of agree with that. Reasonable people could disagree, but I do agree that this seems harder to read because, like, I start reading here, but wait a minute, getString is going to get used first, and then it's going to give me back a value. So yeah, it just feels like it was nicer to read top to bottom, I would say. Your thoughts? Yeah, and so this is useful if I only want to print out the person's name once. If I want to use it later in a longer program, I'm out of luck. And so I haven't saved it in a variable. So I think, long story short, we could sort of debate this all day long. But in this case, like, if you can make a reasonable argument one way or the other, like, that's a pretty solid ground to stand on. But invariably, reasonable people are going to disagree,
that's simple enough,
whether first-time programmers or many years after that. So let's frame this one last example in the context of the same process of taking inputs and outputs. The functions we've been talking about all take inputs, otherwise now known as arguments or parameters, pretty much synonymous. That's just the fancy word for an input to a function. And some functions have either side effects, like we saw, printing something, saying something on the screen sort of visually or audibly, or they return a value which is a reusable value, like name or answer in this case. If we look then at what we did last time, in the world of Scratch last week, the input was what's your name, the function was ask, and the return value was answer. And now let's take a look at this block, which is honestly a more user-friendly version of what we just did with the %s. Last week we said say, then join, then hello and answer. But the interesting takeaway there was not how to say hello anything. It was the fact that in Scratch 2, the output of one function, like the green join, could become the input to another function, the purple say. The syntax in C is admittedly pretty different, but the idea is essentially the same. Here, though, we have hello, a placeholder, but we have to, in this world of C, tell printf what we want to plug in for that placeholder. It's just different, but that's the way to do it. When we get to Python and other languages later in the term, there's actually easier ways to do this, but this is a very common paradigm, particularly when you want to format your data in some way. All right, let's then take a step back to where we began, which was with that whole program, which had the include, and it had int, main, void, and all of this other cryptic syntax. This Scratch piece last week was kind of like the go-to whenever you want to have a main part of your program. It's not the only way to start a Scratch program. You could listen for clicks or other things, not just the green flag, but this was probably the most popular place to start a program in Scratch. In C, the closest analog is to literally write this out. So just like last week, if you were in the habit of dragging and dropping when green flag clicked, as a C programmer, the first thing you would do is, after creating an empty file, like I did with hello.c, you'd probably type int main void, open curly brace, close curly brace, and then you can put all of your code inside of those curly braces. So just like Scratch had this sort of magnetic nature to it, where the puzzle pieces would snap together, C, as a text-based language, tends to use these curly braces, one of them opened, the other one closed, and anything inside of those braces, so to speak, is part of this puzzle piece, aka main. So what was atop them? We went down this rabbit hole a moment ago with these things called header files, even though I didn't call them by this name. But indeed, when we have a whole program in Scratch, super easy. Just have the when green flag clicked and then say hello world. There's no special syntax. After all, it's meant to be very user-friendly and graphical. In C, though, you technically can't just put int main void printf hello world. You also need this because, again, you need to tell the compiler to load the library, code that someone else wrote, so that the compiler knows what printf even is. You have to load the CS50 library whenever you want to use getString or other functions like getInt, as we'll soon see. Otherwise, the compiler won't know what getString is. You just have to do it this way. The specific file name I'm mentioning here, standardIO.h, CS50.h, is what C programmers call a header file. We'll see eventually what's inside of those files, but long story short, it's like a menu of all of the available functions. So in CS50.h, there's a menu mentioning getString, getInt, and a bunch of other stuff. And in standardIO.h, there's a menu of functions, among which are printf. And that menu is what prepares the compiler to know how to implement those same functions. All right,
Let me just. Yeah, we're back. Sorry about that. Had to receive a package. So yeah, let's continue.
let me pause here. Question. Not quite. A library
What happened?
provides all of the functionality we're talking about. A header file is the very specific mechanism via which you include it. And we'll discuss this more next week. For now, they're essentially the same, but we'll discuss nuances between the two next week. Yeah, the library would be standard IO. The library would be CS50. The corresponding header file is standardIO.h, CS50.h. Indeed. Other questions? Yeah. Indeed. That too is on the menu. We'll come back to that. But the word string, incredibly common in the world of programming. It's not a CS50 idea. But in C, there's technically no such data type as string by default. We have sort of conjured it up to simplify the first few weeks. That's a training wheel that we'll very deliberately in a few weeks take away. And we'll see why we've been using getString and string, because C otherwise makes things quite more challenging early on, which then gets besides the point for us. Yeah? Yes, early on, you will have to use whatever's prescribed by the specification. That will include CS50's functions. Long story short, you referred, I think, a moment ago to another function called scanf. We won't talk about for a few weeks. Long story short, in C, it's pretty easy and possible to get input from a user. The catch is that it's really easy to do it dangerously. And C, because it's an older, lower level language, so to speak, that gives you pretty much all ultimate control over your computer's hardware, it's very easy to make mistakes. And indeed, that's too why we use the library, so your code won't crash unintendedly. All right, so with this in mind, we have this now mapping between the Scratch version and the other. Let me just give you a quick tour of some of the other placeholders and data types that we'll soon start seeing as we assemble more interesting programs. In the world of Linux, here is a non-exhaustive list of commands with which you'll get familiar over the next few weeks by playing with problem sets. We've only seen 2 of these so far, ls for list, rm for others. But I mention them now just so that it doesn't feel too foreign when you see them on screen or online in a problem set. CP is going to stand for copy. Makedir is going to stand for make directory. MV is going to stand for move or rename. RMdir is going to be remove directory. And CD is going to be for change directory. Yeah. And let me show you this last one here first, only because it's something you'll use so commonly. If I go back to my code here on the screen, I'm going to go ahead and reopen the little GUI on the left-hand side, the so-called Explorer, revealing that I've got 2 files, hello and hello.c. So nothing has changed since there. Suppose now that it's a few weeks into class, and I want to start organizing the code I'm writing so that I have a folder for this week or next week, or maybe a folder for problem set 1, problem set 2. I can do this in a few ways. In the GUI, I can go up here and do what most of you would do instinctively on a Mac or PC. You look for like a folder icon, you click it, and then you name a folder like pset1, enter. Voila, you've got a folder called pset1. I can confirm as much with my command line interface by typing what command?
ls.
How can I list what's in my folder? Yeah, so ls for list. And now I see hello, and it's green with an asterisk because that's my executable, my runnable program. Hello.c, which is my source code. And now pset1 with a slash at the end, which just implies that it's indeed a folder. All right, I didn't really want to do it that way. I'd like to do it more advanced. So let me go ahead and right-click on pset1, delete permanently. I get a scary irreversible error message, but there's nothing in it, so that's fine. Now I've deleted it using the GUI. But now let me go ahead and start doing the same thing from the command line. And if you're wondering how things keep disappearing, if you hit Control L in your terminal window or explicitly type clear, it will delete everything you previously typed just to kind of clean things up. In practice, you don't need to be doing this often. I'm doing it just to keep our focus on my latest commands. If I do, what was the command to make a new directory?
md.
Yeah,
space.
so make dir, make directory. Let me create
mkd.
pset1, enter, and notice it left. There's my pset1. If I want to get a little overzealous, plan for next week, here's my pset2 directory. Suppose now I want to open those folders, one on Mac or PC or in this GUI. I could double click on it like this, and you'd see this little arrow is moving. It's not doing anything because there's nothing in there, but that's fine. But suppose, again, I want to get more comfortable with my command line. Notice if I type ls
space,
now,
the
I
name of
see
the
all 4
directory.
same things. Let me change directories with cd space pset1, enter. And now notice 2 things will have happened. One, my prompt has changed slightly to remind me where I am, just to keep me sane so that I don't forget what folder I'm actually in. So here is just a visual reminder of what folder I'm currently in. If I type ls now, what should I see after hitting enter? Nothing, because I've only created empty folders so far, and indeed, I see nothing. If I wanted to create a folder called Mario for a program that might be called Mario this week, I can do that. Now if I type ls, there's Mario. Now if I do cd Mario, notice my prompt's going to change to be a little more precise. Now I'm in pset1/Mario. And notice what's happening at top left. Nothing now because these folders are collapsed. But if I click the little triangle, there I see Mario. Nothing's going on in there because there's no files yet. But suppose now I want to create a file called mario.c. I could go up here. I could click the little plus icon and use the GUI. Or I can just type code mario.c. Voila. That creates a new tab for me. I'm not going to write any code in here yet, but I am going to save the file. And now at top left, you'll see that mario.c appears. So at some point, you can eventually just close the Explorer. Because again, it's not providing you with any new information. It's maybe more user-friendly, but there's nothing you can't do at the command line that you could do at the GUI. All right, but now I'm kind of stuck. How do I get out of this folder? In my Mac or PC world, I'd probably click the back button or something like that, or just close it and start all over. In the terminal window, I can do cd ... is a nickname, if you will, for the parent directory. That is the previous directory. So if I hit enter now, notice I'm going to close the Mario folder, aka directory, and now I'm back in pset1. Or if I want to be fancy, let me go back into Mario temporarily. If I type ls, there's mario.c, just to orient us. If I want to do multiple things at a time, I could do cd //, which goes to my parent to my grandparent, all in one breath. And voila, now I'm back in my default folder, if you will. And one last little trick of the trade, if I'm in pset1/Mario, like I was a moment ago, and you're just tired of all the navigation, if you just type cd and hit enter, it'll whisk you away back to your default folder. And you don't have to worry about getting there manually. Recall a bit ago, though, that I was running hello as this, /hello. If ... refers to my parent, perhaps infer here syntactically, what does a single dot mean instead?
Current directory.
It means this directory, your current directory. Why is that necessary? It just makes super explicit to the computer that I want the program called hello that's installed here, not in some random other folder on my hard drive, so to speak. I want the one that's right here instead. All right, so besides these commands, there's going to be others that we encounter over time. Those are kind of the basics. That allows you to sort of wean yourself off of a GUI, a graphical user interface, and start using more comfortably, with practice and time, a command line interface instead. Well, what about those other types now, back in the world of C? Those commands were not C. Those are just commands specific to a command line interface, like in Linux, which again we're using in the cloud. It's an alternative to Mac OS and Windows. Back in the world of C now, we've seen strings, which are words. I mentioned int or integer, but there's others as well. In the world of C, we've seen string. We will see int. If you want a bigger integer, there's something literally called a long.
Oh.
If you want a single character, there's something called a char. If you want a Boolean value, true or false,
yeah.
there is a bool. And if you want a floating point value, a fancy way of saying a real number, something with a decimal point in it, that is what C and other languages call a float. And if you want even more
Bigger
numbers after the decimal point, that is more precision, you can use something called a double. That is to say, here's again an example in programming where it's up to you now to provide the computer with hints, essentially, that it will rely on to know that what is this pattern of zeros and ones? Is it a number, a letter? Is it a sound, an image, a color, or the like? These are the types of data types that provide exactly those hints. What are the functions that come in the menu that is the CS50 library? We talked about standard I/O, and that's just one function so far, printf. In the CS50 library, you can see that it follows a pattern. The CS50 library exists largely for the first few weeks of the class to make our lives easier when you just want to get user input. So if you want to get a string, like a word or words from the human, you use getString. If you want to get an integer from the user, you're going to use getInt. When you want to get any of those other data types, for the most part, you use get underscore something else. And they're indeed all lowercase by convention. What about printf? If we have the ability now to store different types of data, and we have functions with which to get different types of data, how might you go about printing different types of data? Well, we've seen %s for string, %i for integer, %c for char, %f for a float or a double, those real numbers I described earlier, and then %li for a long integer. So here's the first example of like inconsistencies. In an ideal world, it would just be %l, and we'd move on. It's %li instead in this case. That's printf and some of its format codes. What more might we do? Well, in C, as we'll see, no pun intended, there's a whole bunch of operators. And indeed, computers, one of the first things they did was a lot of math and calculation. So there's a lot of operators like these. Computers, and in turn C, really good at addition, subtraction, multiplication, division, and even the percent sign, which is the remainder operator. There's a special symbol in C and other languages just for getting the remainder when you divide one number by another. There are other features in the world of C, like variables, as we've seen. And there's also what is sort of playfully called syntactic sugar that makes it easier over time to write fewer characters but express your thoughts the same. So just as a single example of this, consider this use of a variable last week. Here in Scratch is how you might set a variable called counter to 0. In C, it's going to be similar. If you want the variable to be called counter, you literally write the word counter, or whatever you want it to be called. You then use the assignment operator, aka equal sign, and you assign it whatever its initial value should be here on the right. So again, the 0 is going to get copied from right to left into the variable because of that single equal sign. But this isn't sufficient in C. What else is missing on the right-hand side instinctively now, even if you've never programmed in this before? Yeah, in front. A semicolon at the end, and one other thing I think is probably missing. Again? A data type. So what would you, if we can keep going back and forth here, what data type seems appropriate intuitively for a counter? Int for integer. So indeed, we need to tell the computer when creating a variable what type of data we want, and we need to finish our thought with the semicolon. So there might be a counterpart there. What about in Scratch if we wanted to increment that counter variable? We had this very user-friendly puzzle piece last time that was change counter by 1, or add 1 to counter. In C, here's where things get a little more interesting and pretty commonly done. You might do this. Counter equals counter plus 1 with a semicolon. And this is where, again, it's important to note the equal sign, it's not equality. Otherwise, this makes no sense. Counter cannot equal counter plus 1, right? Like, that just doesn't work if we're talking about integers here.
It's an increment
operation. That's because the equal sign is assignment. So it can certainly be the case that you calculate counter plus 1, whatever that is. Then you update the value of counter from right to left to be that new value.
Yeah.
This, as we'll see, is a very common thing to do in programming, just to kind of count upward for whatever reason. You can write this more succinctly. This code here is what we'll call syntactic sugar. Sort of a fancy way of saying the same thing with fewer words or fewer characters on the screen.
Much better
this also adds 1, or whatever number you type over here, to the variable on the left. And there's one other form of syntactic sugar we're going to start seeing too. And it's even more terse than this. That too will increment counter by 1. By literally changing its value by 1, or if you change it to minus minus, subtracting 1 from it. You can't do that with 2 and 3 and 4, but you can do it by default with just plus plus or minus minus, adding or subtracting 1. Yeah? So when you are changing a variable that already has been created, as we did with the code that looked like this, you no longer need to remind the computer what the data type is. Thankfully, the computer,
change the value,
at least as smart as that, it will remember the type of the data that you intended. Other questions or comments on this? All right, that's quite a lot. Why don't we go ahead and here take a 10-minute break, and we'll be back. We'll start writing some code. All right. So we are back. We've just looked at some of the basics of compiling, even if it doesn't quite feel that basic. But now let's actually start focusing really on writing more and more code, more and more interesting code, kind of like we dove into Scratch last week. So here I have VS Code open. I've closed the GUI. I'm going to focus more on my terminal window and my code editors. Many different ways I can create new files, but I want to create something called a calculator. So again, within this environment of VS Code, I can literally write the code command, which is VS Code specific, and it just creates a new file for me automatically. Or I could do that in the GUI. I'm going to go ahead and create this file called calculator.c. And I'm going to go ahead and include some familiar things. So I'm just going to go ahead and proactively include cs50.h, standardio.h. I'm going to go ahead from memory and do the int void main. More on that next week, why it's int, why it's void, and so forth. And now let me just implement a very simple calculator. We saw like some mathematical operators like plus and the like. So let's actually use this. So let me go ahead and first give myself a variable called x, sort of like grade school math or algebra. Let me go ahead then and get an int, which is new, but I mentioned this exists. And then let me just ask the user for whatever their x value is. The thing in the quotes is just the English or the string that I'm printing on the screen. So I could say anything I want. I'm just going to say x colon to prompt the user accordingly. Now I'm going to go ahead and get another variable called y. I'm going to get int again. And now I'm going to prompt the user for y. And I'm just very nitpickily using a space just to like move the cursor so it doesn't look too messy on the screen. And then lastly, let me go ahead and just print out the sum of x and y. In an ideal world, I would just say something like printf x plus y. But that is not valid in C. The first argument, recall, in printf has to be a string in double quotes. So if I want to print out the value of an integer, I need to put something in quotes here, maybe followed by a new line if I want to move the cursor as well. So again, we only glimpsed it briefly, but what do I replace these question marks with if I want a placeholder for an integer?
%i.
Yeah, so %i, right? Just like %s was string, %i is integer. So I change this to %i. And now if I want to add x and y, for instance, super simple calculator, doesn't do much of anything other than addition of two integers. I think this works. And again, it looks definitely cryptic at first glance. Like it would be nice if programming weren't this cryptic. Other languages will clean this up for us. But again, if you focus on the basics, printf takes one input first, which is a format string. With English or whatever language, some placeholders maybe. Then it takes potentially more arguments after the comma, like the value of x plus y. All right, let me go ahead now and make calculator, which again compiles my source code in C, pictured above, and converts it into corresponding machine code or zeros and ones. No error messages, so that's already good. Now I do /calculator. Let's do 1 + 1 and enter. Voila. Now I have the makings of a calculator. Now let's start to tinker with this a little bit. What if I instead had done this? Int z gets x plus y, and then plug in z here. If I rerun make calculator, enter, rerun / calculator, type in 1 plus 1, still equals 2.
It's a variable.
And let me
Stored in a
claim that it will
variable.
work for other values as well. Which of these versions is better designed? If both seem to be correct at very cursory glance, is this version better, or is the previous one without the z?
I think
OK,
that
so this one's
better.
arguably better because I've now got a reusable variable called z that I can not only print, but heck, if my program's longer, I can use it elsewhere. Counter thoughts? Yeah, debatable like before because it depends on my intent. And honestly, I think a pretty good argument can be made for the first version because if I have no intention of, as you note, using that that variable again, you know what? Maybe I might as well do this just because it's one less thing to think about. It's one less distraction. It's one less line of code to have to understand. It's just a little tighter. So
Yeah,
here
just
again, I think it does depend on your intention. But this feels pretty reasonable. And I think, as someone noted earlier, when I did the same thing with getString, that, yeah, maybe kind of crossed a line because getString and the what's your name inside of it was just so much longer. But x plus y, it's not that hard to wrap our mind around what's going on inside of the printf argument. So again, these are the kinds of thoughts that hopefully you'll acquire the instinct for, not necessarily reaching the same answer as someone else. But again, the thought process is what matters here. All right, so how might I enhance this program a little bit? Let's just talk about style for just a moment. So x and y, at least in this case, are pretty reasonable variable names. Why? Because like that's the go-to variable names in math when you're adding two things together. So x and y seem pretty reasonable. I could have done something like, well, maybe my first variable should be called first number, and my next variable should be called second number. And then down here, I would have to change this to first number plus second number. Like this isn't really adding anything semantically to help my comprehension, but that would be one other direction we could have taken things. So if you have very simple ideas that are conventionally expressed with common variable names like x and y, totally fine here. What if I want to annotate this program and remind myself what it is it does? Well, I can add in C what are called comments. With a // 2 forward slashes, you can write a note to yourself, like prompt user for x. And then down here, I could do something like prompt user for y, just to remind myself what I'm doing there. And down here, perform addition. Now, in this case, not sure these comments are really adding all that much, because in the time it took me to write and eventually read these comments, I could have just read the 3 lines of code. But as our programs get more sophisticated and you start to learn more syntax that honestly you might forget the next day, the next week, the next month, might be useful to have these sort of notes to self that remind you of what your code is doing, or maybe even how it is doing that thing. With these early programs, not really necessary, doesn't really add all that much to our comprehension, but it is a mechanism you have in place that can help you actually remind yourself or remind someone else what it is that's going on. Well, let me go ahead and rerun this again in this current version, make calculator. And here, too, you might think I'm typing crazy fast. Not really. I'm hitting tab a lot. So it turns out that Linux, the operating system we're using here in the cloud, but actually Windows and Mac OS nowadays support this too, supports autocomplete. So if you only have one program that starts with CAL, you don't have to finish writing calculator. You can just hit tab, and the computer will finish your thought for you. The other thing you can do is if you hit up and keep going up, you'll scroll through your entire history of commands. So there, too, I've been saving some keystrokes by hitting up quickly rather than retyping the same darn thing again and again. So again, just another little convenience to make programming and interacting with the command line interface even faster. All right, let me go ahead and just make sure it's compiled in the current form. The comments have no functional impact. These green things are just notes to self. Let me run calculator with maybe, how about this? Instead of 1 plus 1, how about 1 billion? Oops, let's do that again. 1 million, 1 billion, and another 1 billion. And that answer is 2 billion. All right, so that seems correct. Let's run this program one more time. How about 2 billion plus another 2 billion? Did you know that?
Has gone over the
apparently
capacity of the
it's not so
integer.
correct, and clearly
type.
running 1 plus 1 was not the most robust testing of my code here. What might have gone wrong? What might have gone wrong? Yeah. Yeah, the computer probably ran out of space with bits. So it turns out with these data types we've been talking about,
Limits. There
string
are
and
limits. Yeah.
int and also
Or
float and char and those other things,
sizes,
they all
capacity.
use a specific and most importantly finite number of bits to represent them. It can vary by computer. Newer computers use more bits. Older computers tended to use fewer bits. It's not necessarily standardized for all of these data types. But in this case, in this environment, it is using 32 bits for an integer. That's a lot. With 32 bits, you can count pretty high. This is 64 light bulbs on the stage and could count even higher. An int is only using half of these, or we have 2 integers here on the stage. Now, if you think back to last week, we talked about 8 bits at one point. And if you have 8 bits, 8 zeros and ones, you can count as high as 256. Just a good number to generally remember as trivia. 8 bits gives you 256 permutations of zeros and ones. 32 gives you roughly how many, if anyone knows? It's 2 to the 32 power. So it's roughly 4 billion, 2 to the 32. If you don't know that, it's fine. Most programmers, though, eventually remember these kinds of heuristics. So it's roughly 4 billion. So that feels like enough. 2 billion plus 2 billion is exactly 4 billion. And that actually should fit in a 32-bit integer. The catch is that my Mac, your PC, and the like also like to support negative numbers. And if you want to support both positive and negative numbers, that technically means with 32-bit integers, you can count as high as roughly 2 billion positive or 2 billion negative in the other direction. That's still 4 billion, give or take, but it's only half as many in one direction or the other. So how could I go about implementing a correct calculator here? What might the solution be? Yeah, so not just li, which was for long integer. I have to make one more change, which is to the data type itself. So let me go back up here and change x from an int to a long, aka long integer. And then let me change y as well. And then let me change the format code per the little cheat sheet we had up a few minutes ago to li. Let me recompile the calculator. Seems to work OK. Let's rerun it. Now let's do 1 plus 1. That should obviously be the same. Now let's do 2 billion and another 2 billion and cross our fingers this time. Now we're counting as high as 4 billion. And we can go way higher than 4 billion, but we're only kicking the can down the street a bit. Even though we're now using, with a long, 64 bits, which is as long as this stage now, that's still a finite value. It might be a really big value, but it's still finite. And we'll come back at the end of today to these kinds of fundamental limitations, because arguably now, my calculator is correct for like millions, billions of possible inputs, but not all. And that's problematic if you actually want to use my calculator for any possible inputs, not just ones that are roughly less than, say, 2 billion, as in this case.
Okay, so we have just finished an hour of lecture for the CS50 Computer Science course. And yeah, most of it has been taking us through the C programming language. And so yeah, as a review, it has been discussed, or several things has been discussed. So there were different command line interface commands that were that has been mentioned, like ways to create directories, or moving to or changing directories within your command line interface, and so on and so forth. And so yeah, another thing that has been mentioned is with functions. So functions is one of the fundamental concepts when doing programming or within programming languages. Okay, so with functions, there are 3 important things you have to remember. Functions have arguments, or things that you can or arguments, or serves as an input. Okay, and then the function itself, and then functions have also side effects, or in other terms, return value. Okay, so a function has those 3 main important points. So yeah, and so yeah, I've also mentioned several of I mean, he has started coding with C, and then he has also like you have also seen that the concepts that we, or the things that have been discussed within the C programming language has been like as you can visually it can be visually represented using the Scratch application, right? So you can see the equivalent parts of the different concepts of the C, okay, with its different constructs. And so yeah, uh, one concept also is when you're within C, you have several data types. So what are data types? Those things that are uh, when you deal with variables in C, you are also dealing with data types. So which means that when you uh, for example, do operations on certain variables, that those variables must have a specific data types, which means that you can have strings, or you can deal with integers or numbers. And so yeah, and also part of that, he has shown us the VS Code IDE. He has also shown us the different uh, functionalities of the IDE. One of that is the syntax highlighting. So when you're dealing with a lot of code, it's important that you can uh, easily identify the different parts of it, like uh, certain certain names and symbols have different colors, so that you can easily identify what part of that is in the code. And so yeah, another thing he also discussed is header files. So within C, it allows you to use header files. So what are those? So basically, they are external programs or external code, right, that you can use within your program. So you can name this as libraries. Okay, so libraries, they are already created programs or code that is available for others to use. Okay, so uh, maybe if you're coding something and then uh, there's tendency that uh, you are dealing with complex programs, then one thing you could do is you can create your own, or what they say, roll your own uh, code. But if there's some alternative, like someone else has already created and built it and tested it thoroughly, then why not just use those libraries or code, okay, in your own programs? So in that case, you don't have to repeat yourself, and then you go to the different, all the trouble that you go through, just yeah, for that specific kind of functionality that you want. So yeah, it consumes a lot of time. Okay, and I also uh, walked us through the different commands that on the IDE itself, for creating directories, changing to the directories, navigating within the different directories. And so yeah, he also quickly showed us that I mean, discussed the operators. So operators are the things that you can use to work with your variables. Okay, like one common example of that would be the arithmetic operators. If you're dealing with numbers, then if you want to add, subtract, multiply, and divide things or numbers, then you can use operators for that. So yeah, it's operators are common in most programming languages, not only in C. Okay. I also mentioned syntactic sugar. So syntactic sugars are like a way to simplify or shorten code. Okay. If there are things that you can that are done like in a uh, long line of code, that you can simplify in a much shorter, but still does the same thing. Okay, one example that he gave was the increment operation. Okay, so with increment, you add number to a variable, and then you set that variable to that number that you added. So he started from, like one example, if you can still remember, the counter is equal to counter plus 1, then you can shorten it into counter plus equal to 1. And then, and the much shorter version of it is the counter plus plus, wherein you use two plus symbols to do the incrementation. But the thing is that you can only do that if you are dealing with or adding 1. But if anything else, you can do the much longer one, the counter plus equal, and then the desired number that you want. to increment a variable. Okay, so it was quite a lot of things that has been discussed for this one. And so yeah, hopefully these things we could remember all of this. And one way to remember is, of course, you can start practicing on the IDE and start, yeah, doing the simple programs like what he did during this hour of lecture. And so yeah, I guess we'll end this session for now, and we will see you back again in our hour number 4 of this CS50 lecture. And so yeah, don't forget to like and subscribe uh, this video, and subscribe to our channel so that you can get updated to future videos and tutorials. And so yeah, I hope you enjoyed this one, and we'll see you again in our next session. Thank you and have a great day, everyone. Yeah, see you soon. Bye bye.